Hey everyone, welcome back to the networking series. In this video, we're going to explore a powerful tool for organizing and managing your network, VLANs, or Virtual Local Area Networks. VLANs are essential for segmenting networks, improving security, and optimizing performance. By the end of this video, you'll understand what VLANs are, how they work, and why they are crucial for modern network management. Let's dive in. First off, what exactly is a VLAN? A VLAN, or a virtual local area network, allows you to logically divide a physical network into separate, isolated segments. This means that even though devices might be physically connected to the same switch, they're placed in different virtual networks, keeping their traffic separate. Think of a VLAN like building virtual walls inside of your network. You can place devices like computers, phones, and printers into different VLANs, even if they're using the same physical cabling or switches. This helps you organize your network based on function, department, and/or security needs. All right, let's break down a simple example. In an office, you might want to separate the traffic from the HR department, the finance department, and the guest network. Instead of physically wiring each department separately, you can use VLANs to keep their traffic isolated, even though they're all using the same network infrastructure. VLANs improve network management in several ways. First, they provide better security. By isolating traffic between departments or groups, you can prevent unauthorized access to sensitive data. For instance, someone connected to the guest VLAN won't be able to access the devices or servers in the finance VLAN. Second, VLANs allow for network segmentation, which means breaking up a large flat network into smaller parts. This helps reduce broadcast traffic, as devices in one VLAN won't see broadcast messages from another VLAN. This improves network performance, especially in large networks. VLANs are also helpful for flexibility and scalability. Since VLANs are virtual, it's easy to move devices from one VLAN to another without physically rewiring anything. This makes expanding and reorganizing your network much simpler. VLANs are configured using managed switches. When you create a VLAN, you assign specific switch ports to that VLAN, and devices connected to those ports become part of the VLAN. A managed switch is necessary because it allows you to configure and control VLAN settings. There are two main types of switch ports that you should be aware of: access ports and trunk ports. Access ports are used to connect end devices like computers, phones, or printers to a specific VLAN. Each access port can only carry traffic for one VLAN, and the switch tags the traffic with the appropriate VLAN ID. Trunk ports, on the other hand, are used to carry traffic for multiple VLANs. Trunk ports are typically used to connect switches to each other or to routers. When traffic travels across a trunk port, it's tagged with a VLAN ID, which tells the receiving switch which VLAN the traffic belongs to. VLAN tagging is what makes this whole system work. VLAN tags are added to the data packet as they travel through the network, indicating which VLAN the packet belongs to. When the packet reaches its destination, the switch or router reads the tag and sends the data to the correct VLAN. But how do VLANs communicate with each other? This is where inter-VLAN routing comes in. Normally, devices on one VLAN can't communicate with devices on another VLAN. If you want to allow communication between VLANs, you'll need a router or a layer 3 switch to route the traffic between them. Inter-VLAN routing allows for controlled communication between VLANs while maintaining that separation. Let's also touch on VLAN trunking protocols. One of the most widely used protocols is 802.1q, which is a standard for tagging VLAN traffic as it passes through trunk links. It allows the traffic for multiple VLANs to be carried over the same physical connection while keeping the VLANs logically separated. There's also something called a native VLAN, which is used when untagged traffic is sent over a trunk link. The native VLAN is the default VLAN for any traffic that doesn't have a tag. It's important to configure this correctly to avoid security risk, as misconfigured native VLANs can lead to VLAN hopping attacks. Finally, let's talk about a few common use cases for VLANs. One common use case is creating a guest VLAN for visitors to your office. This allows guests to connect to the internet without accessing your internal network or your sensitive data. You can also create VLANs for different departments such as sales, IT, and accounting, ensuring that each department's traffic is isolated for better security and performance. Another use case is voice VLANs. Many businesses use VoIP or voice over IP phones, and a voice VLAN helps prioritize voice traffic over regular data traffic, ensuring that calls are clear and don't experience delays or drops. So, to recap, VLANs allow you to logically divide your network into separate segments, providing better security, reducing network congestion, and making network management more flexible. Access ports connect devices to a specific VLAN, while trunk ports carry traffic for multiple VLANs between switches and routers. VLAN tagging helps keep traffic organized, and inter-VLAN routing allows for controlled communication between VLANs. In the next video, we'll be diving into Network Address Translation, or NAT, which lets multiple devices on a private network share a single public IP address when communicating with the internet. Make sure you subscribe so you don't miss it. Thank you all for watching. It really means a lot. I really do appreciate it. Please do me a favor, like, comment, subscribe, and I'll see you all in the next video. Take care.